Subtracting polynomials is very similar to adding, but there is one distinct difference. Remember, a polynomial, no matter what operation we're looking at, is a combination of a bunch of monomials. Well, I got these monomials. All right, great. There they are. And now when I subtract these monomials, when I say subtract a bunch of monomials, what I'm going to be doing is subtracting each individual one. Where I'm subtracting a negative 4x cubed and where I'm subtracting a constant of 2, notice what happens. When I subtract polynomials, notice my first polynomial, all of the signs stayed the same. In my second polynomial, where I say minus 3x to the fourth, that's going to be a negative 3x to the fourth. Where I say minus a negative 4x cubed, minus a negative is plus 4x cubed. Where I say minus 2, that's going to be a negative 2. Notice what would happen to your students. Obviously see the first one, well, okay, it's going to be a minus, but they want to keep those second ones the same. Notice what it does is it changes everything. Where that was a positive 3, it's a negative 3. Where it was a negative 4, it's now a positive 4. Where it was a positive 2, it's now a negative 2. What that subtraction does is changes all the signs in that second polynomial. Another way to look at it, a negative in front really is that negative 1 coefficient. Last time we talked about not wanting to show it for a final answer to be simplified, but it is still there. I can look at it as negative 1 that I want to distribute. Negative 1 times 3x to the fourth, negative 3x to the fourth. Negative 1 times negative 4x cubed is 4x cubed. Negative 1 times 2 is negative 2. Subtracting polynomials, the first polynomial all stays the same. The second polynomial, all the signs switch no matter what way we want to look at it. We could look at it as subtracting each individual term. Not as common. We could look at it as changing the signs, or we could look at it as distributing the negative 1. We have a lot of ways to look at it, but as long as all the first polynomial signs stay the same, all the second polynomial signs change, that's important, and then we combine our like terms. 9x to the fifth, nothing like it. It's going to be my first term because it's the degree, it's my largest exponent. Well, order of descending power, minus 3x to the fourth next because that's the next smallest exponent. Well, then I have 2x cubes. Which one comes first? Since they're like terms, I combine them. And when I combine them, x cubed, my coefficient, even again, though I don't need to recognize it, now it would be important just for record keeping, I have another one. 1x cubed plus 4x cubed ends up being a total of 5x cubed. 4 of them and one more gives me 5. Then I have a minus 9x. Then I have a minus 2. It's totally fine to not have that x squared term. There were no x squared term in either of the polynomials above. We wouldn't expect one here. One other thing that I do want to point out, where my constant here is a negative 2, that's the result of those signs changing. Notice my constant up here. I want to touch on this even though it had nothing to do with the subtraction. When there is no constant, my degree is 5. My leading coefficient is 9. When I have no constant, my constant would be like a plus 0. Just like I can put a 1 in front when it's not there, that's because it's multiplication. 1 times x cubed is x cubed. Plus 0 is still the same polynomial, but that's how I can recognize if I don't have a constant.